From near bankruptcy in the 1990s, NVIDIA's story is one of incredible resilience. With just a big idea, the company rose from a handful of people to a global titan with a market valuation soaring past $3 trillion, now rivaling and surpassing giants like Apple and Microsoft. This is the story of how NVIDIA rose from near bankruptcy to become the beating heart of the new digital age. In the early 1990s, the digital world was taking shape. Computers were becoming common, but the graphics, well, they were blocky, pixelated, and far from immersive. This was the landscape when three ambitious engineers, Jensen Huang, Chris Malachowski, and Curtis Priam, founded NVIDIA in 1993. NVIDIA began as a small startup betting on one idea, that graphics would define the future of computing. Their first product, the NV1, launched in 1995, was a disaster, expensive, poorly optimized, and incompatible with most games. Investors panicked. The company was running out of cash. But it was their next big gamble that truly set them on a path to dominance. That gamble was on PC gaming. In 1999, NVIDIA unveiled the GeForce 256, famously dubbed the world's first GPU, graphics processing unit. This wasn't just another graphics card. It was a dedicated processor specifically designed for rendering visuals, freeing up the main CPU to handle other tasks. This invention unlocked unprecedented levels of realism and speed in games. The GeForce series became synonymous with high-performance gaming. As games became more complex, demanding greater graphical fidelity, NVIDIA's GPUs consistently delivered. They understood that gaming wasn't just a niche. It was a massive, growing market that would push the boundaries of computing. This era solidified NVIDIA's brand, making them a household name among PC enthusiasts, and laying the financial and technological groundwork for their future. But something incredible was happening beyond the world of gaming. Researchers began to realize the unique architecture of NVIDIA's GPUs, designed to process thousands of graphics calculations simultaneously, was perfectly suited for other complex parallel computing tasks. NVIDIA recognized this untapped potential and, in 2006, introduced CUDA, a revolutionary platform that allowed programmers to use NVIDIA GPUs for general-purpose computing. This was a pivotal moment. It transformed the GPU from a mere graphics accelerator into a powerful parallel supercomputer, accessible to scientists, engineers, and researchers worldwide. NVIDIA wasn't just a gaming company anymore. It was a computing company. Fast forward to the 2010, and the world was gripped by the AI revolution. Deep learning, a subset of AI, required immense computational power to train neural networks on vast datasets. And it quickly became clear NVIDIA's GPUs, with their parallel processing prowess and the CUDA platform, were perfectly suited for the job. They could crunch the numbers needed for AI training at speeds no traditional CPU could match. From enabling breakthroughs in image and speech recognition to powering the very foundation of generative AI models like ChatGPT and DeepSeek, NVIDIA GPUs became the undisputed engine of the AI world. Their specialized AI accelerators, like the A100 and H100, are now the gold standard in every major research lab and tech giant building the future of artificial intelligence. NVIDIA didn't just participate in the AI revolution, they fueled it, becoming indispensable. For decades, Intel reigned supreme as the king of computing with its dominant CPUs. But as the world shifted from sequential processing to parallel computing for AI and data, NVIDIA's GPUs began to challenge that long-held supremacy. While Intel still holds a massive share of the traditional CPU market, NVIDIA strategically carved out new territory where its architecture excelled. Intel has certainly tried to compete, developing its own integrated graphics and dedicated GPUs, but NVIDIA's head start with CUDA and its relentless innovation in parallel processing proved incredibly difficult to overcome. This intense, evolving competition pushed both companies to innovate faster, but NVIDIA's early bet on parallel computing truly paid off, redefining the very nature of what a computing company means. NVIDIA's influence now extends far beyond gaming and core AI research. Their GPUs are the backbone of modern data centers, providing the computational horsepower for cloud computing, scientific simulations, and big data analytics. Any major cloud provider, from AWS to Microsoft Azure, relies heavily on NVIDIA's chips to power their most demanding workloads. In the automotive industry, NVIDIA's Drive platform is becoming essential for the development of electric vehicles and autonomous driving. Their chips handle the massive amounts of sensor data, real-time perception, and decision-making required for self-driving cars, turning vehicles into intelligent, mobile data centers. But perhaps one of NVIDIA's most visionary projects is the Omniverse, a platform for building and operating digital twins of real-world factories, cities, and even entire planets. This isn't just a virtual world, it's a real-time, physically accurate simulation platform where designers, engineers, and AI can collaborate and test ideas before they're built in the physical world. Looking ahead, NVIDIA's trajectory points towards an even more profound impact on society. They envision self-sustaining factories designed and operated almost entirely by AI, leveraging digital twins in the Omniverse to optimize every aspect of production, from material flow to energy consumption. These aren't just automated factories, they are intelligent, adaptive ecosystems. Beyond that, NVIDIA is literally building AI factories, massive data centers dedicated solely to training the next generation of AI models, making the process faster and more efficient. Their chips will continue to accelerate breakthroughs in everything from personalized medicine and climate modeling to advanced robotics and the very fabric of the metaverse, creating truly immersive and interactive digital worlds. From pushing pixels in video games to powering the most advanced artificial intelligence, NVIDIA has redefined what's possible in computing. Their GPUs are not just components, they are the catalysts for our digital future. As AI continues to evolve, as data becomes even more central, and as the lines between the physical and digital blur, NVIDIA's influence is only set to grow. The rise of NVIDIA is not just a corporate success story, it's a chapter in the evolution of technology itself. What do you think is NVIDIA's most important contribution? Let us know in the comments below. And if you want to understand the companies shaping our future, don't forget to like this video and subscribe for more insights.